Okay, before we start outside, inside, and on angles, I want to quickly go hit the very last conjecture you made on your geometry sketch pad sheet. Remember when you drew the quadrilateral, and the conjecture is that opposite angles, if you draw, if you inscribe, which means all the vertices are on the circle, if you inscribe a quadrilateral, then opposite angles are supplementary. And if you think about that, that's because like this angle is intercepting this arc, and this angle is intercepting that arc. So altogether, they both intercept a 360-degree arc. So half of that is 180, which is the definition of supplementary. So should have been your conjecture about quadrilaterals. I just wanted to clean that up before we moved on. Okay, so today we're going to talk about relationships of angles and circles. And there are three kinds. When the angle is on the circle, when it's in the circle, and then down here when it is outside the circle. I don't know where my circle went, but like out here. Okay? All right. So first of all, to get an angle on the circle, it has to be a tangent and a secant or chord, because the only way to get the angle on the circle is for this one of the lines to be tangent. Okay? Um, Without it being an inscribed angle, of course. Uh, so the measure of this angle, x, is half the measure of its intercepted arc. So it is like an inscribed angle. So it's on the circle, and the angle of the arc we're talking about is from the left-hand side of the angle, but it doesn't intersect the right-hand side. It goes all the way to the vertex. So when that happens, this angle x is equal to half the measure of its arc. Okay? If the angle is inside, okay, if the angle, like here, this 25, it's inside the circle, okay, so it's two chords or chord and a secant intersecting, okay, then the measure of each angle, because obviously these are going to be the same because they're vertical angles, is half the sum of their intercepted arcs, because now, up until now, we've only had one, it only intersects one arc. But now we have two. We have this arc and this one down here. So the measure of this angle here is equal to 1/2 the sum of the two intercepted arcs. So in this case, 1/2 of 50, which is 25. All right. And then finally, if the angle is outside the circle, so we have either a tangent and a secant, or two tangents or two secants that intersect, okay? And so here are three examples. So here we have a tangent and a secant. Here we have two secants, and here we have two tangents, okay? And this angle that's formed here, the one that the arrow is pointing to for all of these, is the difference of the measure of the two intercepted arcs. Because obviously, again, instead of having just one arc, we've got two. So this angle here has an arc here and an arc here. So the angle is equal to the difference in those two angles. And obviously, it can't be a negative, so you always have to do the larger angle minus this, or the larger arc minus the smaller arc. Okay? All right. Let's let's practice that some. These angles are um, uh, these circles and angles are sort of like a puzzle, just like we were talking about yesterday. And you work them, everything you know, you use everything you know to kind of try to put them together. So looking at this, they gave me arc EH and they gave me arc FJ. So that tells me, hey, I could probably find angle EGH first because this is an angle inside the circle. So I know it's half the measure of the sum of it. There are two angles, so 30 or two arcs. So 31, half of 31 plus 52, which is half of 83, which is 41 and a half. So this angle is 41 and a half, and this angle is 41 and a half. And then angle EGF is a linear pair, so it's 180 minus 41 and a half, which is 38 and a half, 138 and a half. And that one is 138 and a half. Okay, so I'm working through my puzzle. Now, let's look at this angle, angle J here. It is an angle on the circle formed by a tangent line and a secant. So I know that the measure of that angle is half the measure of its intercepted arc. So it's going to be half the measure of 130, and 130 divided by 2 is 65. So this angle is 65 degrees. And this angle, so right now I have all the angles filled out, I think. Well, um, except, no, that's it. Then, well, I could also do like this angle here is just a good old inscribed angle, so I can do half of this. So it's what, 15 and a half? So that's 15 and a half because it's in half of the measure of its arc. And then to find this one, I just add them together. So 140, 153, 154. So that's 26. So this one would be 26 degrees. Now I have all the angles. I have almost all the arcs. I don't have arc EF yet. But I know that inscribed, or that an angle formed inside a circle, like EGF, is equal to this half the sum of its two intercepted arcs. So in this case, 138 and a half is equal to 1/2 of 130, which is arc HJ. That's one of its intercepted arcs, and the one I'm looking for, EF. Okay, so to get rid of the 1/2, I'm going to multiply both sides by 2, and that gives me 277 equals 130 plus x. So I just multiply both sides by 2. Then I'm going to subtract 130 and get 147 equals x. The other way I could have found it is adding, I know that all the way around is 360, so I could have added up all the remaining angles and subtracted from 360 to find that. All right, so take a second and see if you can work this other circle to the right here. Okay, so I tried to fill in all the missing pieces. Um, Now looking at it, I realize I didn't do angle D. So let's do that together real quick. Angle D is outside the circle, so the angle is equal to 1/2 the larger arc minus the smaller arc. So the larger arc is 110 because it's all the way from A all the way over to whatever that point is right there. So that's 110 minus the smaller arc, which we just solved, and it's 12. So one, so 110 minus 12 is 98, and half of 98 is 49. So angle D is 49. All right, we have one more. Give this a try. Let's turn this in tomorrow, please. So find angle Y and the missing arcs and angle V, XVW and XVY and the missing arcs.